Hey guys, hope everybody's doing okay. What we're going to do today is focus on understanding mole conversions. So you already had an introductory lesson on what this number is. What does a mole stand for? It stands for 6.02 times 10 to the 23rd items, just like a dozen stands for 12, a pair stands for 2. A mole is a huge, huge number. So what do we use that number for? We use that number to count things that are really, really small. It's not practical to count I don't know, jelly beans or French fries or anything of a decent size. It's not really practical to count those items in terms of how many moles of them you have because it's not practical. So you have to count something that's really small. Atoms, molecules, particles, in chemistry are really, really, really tiny. So you could have a couple moles of those, and it really sometimes doesn't even add up to that much stuff in terms of a mass of something. So we're going to take a look at that today as we go through different mole conversion scenarios. You'll be doing scenarios involving these conversions throughout this unit and as we go into our next unit on our next two units, really on chemical reactions and stoichiometry. You'll see how this foundation, we just build upon it and we can do some really interesting things with all these conversions. So you have this on your note sheet. You have moles in the middle, is what I would put there, mass on the left, and then atoms, molecules, and particles on the right. Okay? We'll start with the left-hand side first. So we're going to look at mass. How do I convert a number of moles of something? Like if I have 2 moles of something, how much mass would that have? This is where you're going to focus on your periodic table. Okay? So every time you're involving mass in your problem, the periodic table has to be focused on. All right. Looking at the periodic table, we have our elements in their boxes, right? We have a couple numbers in that box. We've really been focusing on the atomic number, like hydrogen is number 1, helium's number 2, lithium's number 3. That was when we had our element quizzes and we had to focus on what numbers we had to memorize. But now we're going to focus on the other number, which is called the molar or atomic mass. Okay, so the molar mass is the mass of 1 mole of that element. So let's use carbon, for example. So if I had 1 mole of carbon, 1 mole of carbon, that's 6.02 times 10 to the 23rd atoms of carbon. If I could somehow count them up, put them on my electronic balance, what would the balance read? Well, it wouldn't really read that high of a value. It would be 12.01 grams. I get that number right here from the periodic table. Okay? So I use my periodic table to get my molar mass when I convert between moles and mass. All right? So 1 mole of carbon would give you 12.01 grams of carbon on the balance. So the unit on your molar mass from your periodic table is really grams per mole. Okay? So grams per mole. 12.01 grams of carbon per 1 mole of carbon. Okay, so as you convert here between mass and moles, you need to look at your periodic table. As you go from moles to atoms, molecules, or particles, we already know that conversion. That was from the introductory video. We're going to work in terms of 1 mole usually. 1 mole of anything has how many atoms, molecules, or particles of that item? Well, it's going to be 6.02 times 10 to the 23rd, right? 1 mole of carbon atoms is 6.02 times 10 to the 23rd carbon atoms. 1 mole of hydrogen atoms is 6.02 times 10 to the 23rd hydrogen atoms. 1 mole is 6.02 times 10 to the 23rd of that item. So that's what we're going to use to convert between moles and atoms, molecules, particles. And we're going to use our periodic table and the molar mass to convert between moles and mass. Okay, so that's what we need to have on this roadmap here. And then we'll be able to easily solve conversion problems based on this information. Okay, so let's go through a couple examples. First one, and you should have a blank note sheet for this. You can copy these down. You want to convert 3.50 grams of phosphorus to moles of phosphorus. So using our conversion roadmap at the bottom of the slide here, we're going to start with grams. We're going to convert into moles. All right, so that's what our problem is going to be. We're going to do factor label method. It's all we use to solve these things, so it's really easy. You want to start with your given information. So it's 3.50 grams of phosphorus. All right, really, really, really important to have your unit, which is grams, and the substance, which is phosphorus. We'll eventually get to problems where we change from phosphorus into something else when we have a chemical reaction. So factor label, set it up. We want to, and we know it's going to be one step, because if we're going from mass to moles here at the bottom, that's one step right here. Okay, so nothing too rigorous so far. Use your factor label rules. You want to cancel out what? You want to cancel out grams of phosphorus. Where does it go if you want to cancel it out? It's going to be on the bottom. Okay? I want to convert into moles. All right, so I'm going to put moles on top. The abbreviation for moles is not going to save you that much time, but it saves you enough time. It's MOL. Okay? So that whole one-letter difference between moles, which M-O-L-E, versus the abbreviation MOL, is what it is. Okay? But what goes here? Well, if you remember, if we go back, when we're working with moles, we want to put 1 next to it. Work in terms of 1 mole. And then when we're using our mass, when we have to solve for mass or we're given mass, we're going to use the molar mass from the periodic table. Okay? So, let's go ahead and do it. 1 mole of phosphorus is what? It's how many grams of phosphorus. You look at your periodic table, you find phosphorus, and it should be 30.97. So we have 30.97 grams of phosphorus. There's 30.97 grams of phosphorus in 1 mole of phosphorus. So cancel out grams of phosphorus. Sig figs, we should have 3, because 3.50 has 3 sig figs. Pop in your calculator 3.50 divided by 30.97, and you get 0.113 moles of phosphorus for your answer on that one. Okay? Simple one-step mole conversion. 1 is always going to go next to moles for now, and then anytime you have a unit of mass, which is grams, you put your molar mass next to it. Let's do another one. Convert 2.75 moles of calcium fluoride to grams of calcium fluoride. So again, go down here. We're at moles. It's 2.75 moles of calcium fluoride into grams. So we're going backwards. Still going to be 1 step, right? 1 step right here that we have to do. A couple other things we need to worry about. Calcium fluoride, you need a formula for that. So that's CaF2 from our nomenclature unit. Calcium's a +2, fluoride's a -1. So let's go ahead and solve it. So 2.75 moles of calcium fluoride. It's going to be 1 step, so I set my 1-step problem up. I want to cancel out moles of calcium fluoride. Okay, so where does that go? If I want to cancel it out, it's going to have to go on the bottom. All right, I want to convert into grams of calcium fluoride. Since I want to convert into that, it's going to go on top. Okay, now we haven't really looked at one like this yet. We're still going to have 1 next to moles, because I want to work in terms of 1 mole of calcium fluoride. My equivalence here, just like on the last one, my equivalence is 1 mole of phosphorus is equivalent to 30.97 grams of phosphorus, or 30.97 grams of phosphorus equivalent to 1 mole. It doesn't matter, as long as I have 1 next to moles and 30.97 next to grams of phosphorus, I'm good, right? That's my equivalence. Doesn't matter which one's on top or bottom. If moles is on top or on bottom, the 1 goes next to it. If the 30.97 is grams, or if grams is on top or bottom, the 30.97 goes next to it. All right, same thing over here. But how do I get the mass of calcium fluoride? It's simple. You have to look at your equation, CaF2, and add up 1 calcium. Calcium is 40.08. And then you have 2 fluorines. So you want to make sure you take fluorine, multiply it by 2, and add it up. So fluorine is 19.00. Okay, so 40.08 plus 19 plus 19 gives you a molar mass of 78.08. So you're just using the formula, adding up all the atoms. Okay, so multiply it through. and you get an answer of 214.72 grams of CaF2. But you can only have 3 sig figs in your answer, so that's going to round to 215. All right, 215 grams of, it looks a little sloppy there, but 215 grams of CaF2 for that. Okay, we're going to move on to the other side of our mole conversion roadmap here, and we're going to look at molecules. So if we have 4.50 times 10 to the 23rd molecules of carbon monoxide, convert that into moles. We're going to start here, go here, one step. Okay, so let's set it up. Molecules, you could either write the whole word out or just put M-O-L-E-C. Okay, don't put M-O-L, that's mole. Don't put M-O-L-E, that's mole. You have to put M-O-L-E-C at least. Carbon monoxide is CO. Okay, let's factor label it. You want to cancel out molecules of carbon monoxide. So, just like always, for every factor label problem we've ever done, what you want to cancel out goes on the bottom if it's on top here, which it is. So let's put it on the bottom. And what you want to convert to goes on top. Well, we're doing one step. We're going right into moles. So I'm going to go moles of CO on top. Okay? So what goes next? Well, 1 always goes next to moles, whether it's on top or bottom, doesn't matter. We're working in terms of 1 mole here. If you go back, anytime we're dealing with atoms, molecules, or particles, you use Avogadro's number. Easy. How many molecules of carbon monoxide are in 1 mole of carbon monoxide? Well, it'll be 6.02 times 10 to the 23rd. Molecules of CO cancel. We're left with moles of CO for my final answer. Now, if you look at this, you're doing something times 10 to the 23rd divided by something times 10 to the 23rd. The 10 to the 23rd is canceling out here. So use your calculator appropriately. Okay, if you're having issues, we can talk about it in class. But you shouldn't get a number to the 46th or 48th or whateverth power. Okay, you should get a relatively normal, looking number here. So if you're using your calculator correctly, you'll get a nice normal looking number. If you're not using your calculator correctly, then you're getting something to the 40 whateverth power, and it makes no sense. So think a little bit before you just type it in and write something down for your answer. If you type it in correctly, you'll get to 3 sig figs, so you need 3 in your final answer. You'll get 0.748. moles of carbon monoxide. All right. So let's do one more, I think, where we tie it all together. I want to convert 45.8 grams of sulfur hexafluoride into molecules of sulfur hexafluoride. So sulfur hexafluoride, we have to write the chemical formula for that. SF6, all right. Hexa means 6. This is from our nomenclature unit. I want to go from grams, which is mass. So I'm starting here. I want to go to here. I want to go into molecules. Well, there's no direct way to get there. Okay, I can't go directly from mass into molecules. It's not going to work that way. I have to make a pit stop at moles. Okay, so I need to convert to moles first, and then convert into molecules. No big deal. So how many steps will this be then? 2. So I'll set up a 2-step problem. I'll be good to go. So 45.8 grams of SF6, 2 steps to get my final answer. Okay, we want to go to moles first. That's our first step. So I want to cancel out grams of SF6. It should go where? On the bottom. So grams SF6. And I want to convert to moles first. So that goes on top. Okay. Let's do numbers later. I want to cancel out moles of SF6 because I'm here now, right? I want to go from moles into molecules. So let me cancel out moles of SF6 and go into molecules. Okay, let's fill in some numbers. So anytime I see moles, for right now at least, I'm going to work in terms of 1 mole. So I'm going to put 1 next to moles in both situations here, both steps of my problem. And now I go all the way back to my roadmap here. Anytime I'm dealing with mass, my equivalence comes from the molar mass on the periodic table. So if I go ahead to where we are, my molar mass of SF6 involves me taking a sulfur and then adding 6 fluorines to it. So sulfur is 32.06, and fluorine we looked at is 19.00. You have to multiply that by 6. Okay, so 32.06 plus 19.00 times 6 gives you the molar mass of SF6, which comes out to be 146.06 grams of SF6. Okay, so straight from the periodic table, you figure that out. Last step, I have molecules on top. You know, the one before it, I had molecules on the bottom here. No big deal. Anytime you have molecules, it's 6.02 times 10 to the 23rd that goes next to it. Because that's what my equivalence is. 1 mole of something is 6.02 times 10 to the 23rd of that something. So let's go ahead and finish it off. All right, let's look at what cancels. Grams of SF6 cancel out here and here. Moles of SF6 cancel out here and here. What am I left with? Molecules of SF6, which is what I want. 45.8 divided by 146.06 times 6.02 times 10 to the 23rd. Knock it out, 3 sig figs, and you end up with 1.89 times 10 to the 23rd molecules of SF6. Okay? That is how to do mole conversions. Okay, so it really doesn't get much more complicated than these for right now. We're going to take pieces of this and parts of this and expand on it as we go throughout the unit and as we go throughout the next 2 units. So the main takeaway here is factor label. Units, really, really important. Labels, really important. Getting those good habits now. If you have moles, you put a 1 next to it. If you have molecules, atoms, particles, you put 6.02 times 10 to the 23rd next to it. And if you have a mass, grams, use your molar mass from the periodic table. Okay? You guys will have a chance to work on some practice problems. It's really just using the factor label method, like I said, using some different equivalences. So it all depends on the substance that you're given. So if this is an Edpuzzle, you could look at the assignment and it'll post some of the practice problems you have to do. And we could talk about some of those and go over those in class. All right, thanks guys.